Thank you for joining us and welcome to the Housing Supply Solutions Showcase. This session is being recorded and will be available after the event. My name is Sam Cater, Vice President, Chief Economist for Freddie Mac. I am delighted to be joined today by the faculty at the School of Architecture, Planning and Landscape Architecture at Auburn University's Rural Studio. We are joined by Emily McGlone, Rusty Smith, Betsy Farrell-Garcia, Mackenzie Stagg. And today we will be addressing the affordable housing shortage and developing strategies for increasing housing supply in rural markets. With that, let's begin. Emily?
Thank you, Sam, for introducing us. My team and I are really happy to be a part of the Rural Research Symposium. And the Front Porch Initiative is, as in the title of our presentation, is part of Auburn University's Rural Studio, which is a field unit of the School of Architecture. We are a design-build, hands-on program located in rural West Alabama. And in a typical year, we have between 30 and 45 students. And for 27 years, we've been working in the underserved communities of Hale, Marengo, and Perry counties underneath the philosophy that everyone, including rich or poor, deserves good design. We have over 900 alums, and we've built over 175 projects over that time. Rural Studio and the Front Porch Initiative is a fiercely place-based program. We're located in New Bern, Alabama, and we have a service area of about 25 miles. And the students who move out to West Alabama are in their third and fifth year of architecture school. If you're familiar with our work and our program, you probably have seen the hay bale house here. This is the house for the Bryant family. And that's where we started. We started with housing, although it wasn't necessarily replicable or affordable, which is what we're going to talk about today. But we do think that it was beautiful, and we believe that sometimes housing isn't necessarily affordable, but it is decent and beautiful. In these houses in the beginning, they were built out of materials that really had no value, like the sidewalks in the smokehouse there, but until we gave them value. The Rural Studio and the students who build these projects, we also concentrate on community projects, so a commitment to education. As you see in the New Bern Library that was built, it was an old bank, and it's now the only place for free high-speed internet in our town of 300 people. We have a commitment to fitness, and we've done 2 pretty large multi-year fitness parks. So this is a skate park that 4 students built. There's also baseball fields and a playscape here, as well as a Boy Scout hut. We're also committed to supporting existing programs in our community, like Boys and Girls Club. Again, 4 students built this project. And we're also a program that is committed to housing and to food security. So we grow our own food, we cook the food that we grow, and our students eat the food. And this is it's all part of the service aspect of our program. The students work in the greenhouse to grow their food. And then because we believe that food security next to housing is one of the most important aspects of a healthy community. And of course, as architects, we believe in the health, safety, and welfare of our community. And in this particular project, which is a fire station built by 4 students for our town, this also supports our mission of affordable housing. And what do I mean by that? Well, a fire station in your community makes homeowners insurance possible, and insurance makes financing possible for a house. And then, of course, financing means that you'll have a title to a real property, which which supports the family and the community. But I'd like to focus back to housing and talk about where we are now. So this was a common scene 20 years ago when we first started at the Rural Studio. But the housing stock has changed, and the trailer house is really what we see more of today. And the reasons for that is this new reality is that it's easily attainable. It's kind of like getting a car note. Most of you probably know. It has really only a 15-year lifespan, though. They're really hard to repair, and they're not really affordable at the end. But a lot of our clients own their own property already, so it's easy to buy a house and place it there. So we do understand, but we are seeking a better solution. So around 14 years ago, we started the 20K house project, and we've developed a series of prototypes to address housing affordability. And over the years, we've built over 26 of them. So here's my chance to remind you again that this is all student work. Between about 4 students build each one of these projects. The students in the 5th year of their study, they work on big topics like maybe aging in place or issues of accessibility. But we always address some very central criteria in our houses, which all buildings should. They should be durable and buildable, waterproof, and secure. But over the 14 years, we've developed a series of other criteria that are important to us. Essentially, high performance criteria in one way. The presence is important to us. So being proud and a house that is dignified, a house that fosters a sense of community, which is often accomplished with a porch. All of our houses place importance on that, building community. Of course, the health of our occupants is really important. So our houses look at access to daylight and to fresh air and to healthy materials. And of course, accommodation, making sure that we have houses or housing types that everyone can use, even if you have mobility impairments. And then also the houses should convey a sense of craft, because even something that's affordable should be well put together. But I think the most important part of our program, keep reiterating it, is that architecture students build this. We are a hands-on program, so they are gaining knowledge about how to put buildings together, and our community is benefiting from their energy and their dedication. I mentioned that the older students look at broad issues, and I want to take a minute to walk you through what the younger students study, which are my group of students, the 3rd-year architecture students. We take one of 3 of the prototypes each year, and we study it very intently. And if the 5th-year students are studying broad issues, we're studying really deep and detailed issues. My students look a lot like this. They're about 20 to 21 years old, don't have very much construction experience, and they've actually never had any experience probably working with a real client and finding a suitable house for that individual. This year's client is a lady named Ophelia Reed. She was born in our hometown of New Bern, has lived there for over 50 years. She has a very strong family network, and she also has an existing house and owns a piece of property. So when we were selecting which house was most appropriate for Ophelia, we took all of those things into consideration. One of the unique things about Ophelia and the way that we learn from Ophelia is that I have my students do really detailed and beautiful drawings of her way of life. It's kind of like an interview, but through observation. And one of the observations that my students made was that she really loves her daybed, where she likes to sleep in the living room, where the TV is, and where all of the family activity is. So, and special things like that for our client, we really take into account. So this is a furniture layout. So a lot of the houses that we build are about 500 square feet, but Ophelia is moving from a house that's almost 1,200 square feet. So we catalog all of her belongings, ask her what she'll be taking over to the new house. We learn about her through, this is a graphite rendering of students do. We can see that connectivity is really important to Ophelia through all of the satellite dishes that remain in the yard over time. And I think one of the most important things that the Front Porch Initiative and the Rural Studio gather from this is how flexible are the prototypes to fit onto an existing piece of property, which is really one of the the missions of the 20K house. So you can see here that Ophelia owns about a third of an acre, and we can only build on 1/3 of that third of an acre. So Ophelia's house is essentially a cousin of the prototype. So you can see on the right, or on my right, the modified house plan. We enlarged the floor plan just a little bit, and we built a little sleeping nook into the living room. So Ophelia can put her daybed into the house, but another client might put a home office there, or it might be used for additional storage. So these little tweaks are the way that we adjust our houses to the real people who will occupy them, which is really the most important part. So you can see Ophelia's house is actually the third iteration of the original one, which was what we call Joanne's. I'm very proud, and as my colleagues are, who work for the Rural Studio and in the Front Porch Initiative, because we really think that we are helping to train the next generation of architects and designers to being thoughtful contributors to the built environment. With that, I'm going to hand the presentation over to Rusty.
Thanks, Emily, and hi, everyone. Today, I'm going to take a few minutes to give you a brief introduction to Rural Studio's Housing Affordability Technical Assistance Program called the Front Porch Initiative. As Emily discussed, over the past 3 decades, Rural Studio has been engaged in the design and construction of numerous affordable housing prototypes in our 5-county service area in the rural Black Belt of West Alabama. The Front Porch Initiative seeks to extend the impact of this applied research, offering housing products and technical assistance to external housing providers currently working to deliver homes in their own under-resourced rural communities. In our own service area, Rural Studio works in a charity model, designing, building, and ultimately gifting houses to homeowners that under no circumstances could provide a home for themselves. The Front Porch Initiative simply takes the knowledge we have developed through these decades of work and shares it with housing providers outside our traditional service area so they can in turn provide the same energy efficient, resilient, and healthy homes to their clients of need and through their own procurement models. We currently have 4 product lines of houses, each named after the first clients to own each of the prototypical homes. Each of the 1 and 2 bedroom houses are small, but not tiny. They are designed to be as efficient as they can be, meet all conventional code and lending requirements, be titled as real property, and be lived in normally. Here we have Dave's house, MacArthur's house, Joanne's house, and Buster's house. In the Front Porch Initiative Technical Assistance Program, we share our knowledge on what to build relative to codes, universal design standards, lending and insurance requirements, and the like. And we also share our know-how, where we show what to build through a comprehensive set of construction documents and specifications for each of the houses. We are currently working with a network of field test partners throughout the Southeast, and here's just one of the early examples of homes built in Chattahoochee Hills, Georgia. Through these partnerships, we have learned a number of things. First, it's not only important to show what to build, we now know we have to show how to build it, and even more importantly, why it's built that way. We are all familiar with the IKEA model, where we provided a catalog of materials, a funny little tool, and a really clear and comprehensive set of step-by-step instructions through which we can all become competent furniture builders. With our builder partners, we provide the same kind of instructional documents for the house. We know every single detail about how the house is assembled, and we know every single thing about the construction sequence. From this, we are able to provide a set of instruction documents that walk them step by step through both the hows and the whys of the construction of each home. This notion of why we build this way versus that way is key in addressing the fundamental challenges of affordability. While it is certainly important to ask, what does a house cost to build? It is perhaps more useful to consider what a house actually affords. In other words, what impact might we have on affordability if we could begin to consider the total cost of homeownership in the overall financial equation? More directly, we have found that our homeowners are not primarily challenged because they can't afford their mortgage, which in rural places is often simply a direct reflection of the upfront costs of construction. Instead, they are more often challenged to stay in their homes because of more of the four following circumstances. First, they may have an unexpected energy bill. In our part of the world, our homeowners may have an energy bill of $35 to $45 a month in March and April, and an energy bill of $350 to $400 in July and August. The second thing that happens, they may have an unexpected maintenance or repair bill. We live in an area of highly volatile climatic activity. We live right in the middle of Tornado Alley and right in the catcher's mitt of the Gulf Coast, where every Gulf hurricane pauses directly overhead as it becomes a tropical storm. Maintenance and repair due to storm-related events plays a significant role in the financial security of our homeowners. Third, our homeowners might have an unexpected healthcare event in their lives. And the fourth area of influence on our homeowners' financial well-being is that our homeowners rely predominantly on part-time work, shift work, and seasonal work to make ends meet, and additional live in complex kinship networks in which everything is shared, from housing, transportation and income, to food, elder care, and child care. Any disruption in these community networks can be disastrous for generations of a family. So in addition to managing the upfront cost of construction of the home, it is even more important and impactful to understand how the actual performance of the home in the four key areas of energy efficiency, durability, and resilience, health and well-being, and the strengthening of community networks all contribute in profound ways to financial and economic security. Lastly, working with our builder partners and homeowners, the Front Porch Initiative provide the information, knowledge, and know-how around each of these instrumental areas to help them make informed decisions with regard to the quantitative and qualitative aspects of building performance, all of which allow a clear decision tree that considers both the cost and value of action, as well as the hidden cost of inaction. Taken together, this iterative process of evaluating both the cost and value of building performance criteria around a particular housing provider's unique needs and desired outcomes lends itself to a highly customizable process that yields a wide variety of housing options and variations. Now, to help understand more about building performance matters, or how it matters, Betsy will take a little deeper dive into a case study of energy efficiency. Betsy?
Thanks, Rusty. So I'll share a case study of 2 iterations of one of our product line homes and how we incorporated multiple building standards. Auburn Opelika Habitat for Humanity is our local Habitat affiliate. We have a long history with them, and they were one of our first external partners outside Hale County, Alabama. These 2 houses were a partnership with architecture and building science students as volunteer labor, with a professional contractor acting as the project manager coordinating subs. In this aerial, we can see the confluence of 2 street grids and the odd-shaped parcels that result. The orange outlines show property lines on 2 parcels that remained in the affiliate's portfolio for years. They were unable to utilize them because their traditional 3 to 4 bedroom homes would not fit. The introduction of our 2-bedroom prototype unlocked these in other parcels. It increases property value because they can now be improved, and it expanded the affiliate's client base beyond families who need that larger 3 to 4 bedroom house. Now they serve smaller families. The site plan shows how the houses fit on the sites within their setbacks. House 66 at the top of the screen was built in 2018, House 68 in 2019, and they are the same house, a 2-bed, 1-bath prototype. Both were built to fortified gold, high wind and hail, a structural resilience standard, but to 2 different energy standards. The first house was built to passive house at the top of this diagram. The second house was built to the less rigorous Zero Energy Ready Home standard. We built to the more stringent standard first, and then brought that knowledge to bear on the second project. Our understanding of the prescriptive FIAS standard was valuable when applying the descriptive Zero Energy Ready Home standard the following year. So we've analyzed our construction detailing and compared major differences in construction cost, and these are the 5 primary areas where the homes differ. We'll start by comparing the foundation and floor detail, beginning with insulation shown in pink. You'll notice that the House 66 detail, built to passive house, shows substantial underslab insulation with an upturn at the edge of slab dictated by our energy model in design. In the photo at right, you can see that the underslab insulation is continuous across the footprint. This represents substantial cost. By comparison, House 68 includes only an edge of slab thermal break. Energy code in climate zone 3 requires neither under slab nor edge of slab insulation. However, from our experience of building to the FIA standard, we understood the importance of a thermal break in minimizing heat loss through the stem wall. So for the second home, we simply provided vertical board insulation at the inside face of wall. Because we were applying a structural standard as well, we needed to provide rebar and anchor bolts to satisfy continuous load path requirements of Fortified. At House 66, this necessitated a site-formed concrete curb to accommodate those. The photo at right shows additional tie-downs dictated by an intermediate Fortified inspection. We were told to include more anchorage at corners, but could not provide without compromising the perimeter air sealing. To apply them to the face of exterior wall, we had to cut into our Termite Shield for the straps to lay flat. The time and labor to execute this curb detail motivated us to reconsider the top of wall detail for the second home, hence the simpler detail at right. Our 8-inch CMU bond beam accommodates rebar and bolts comfortably. We incorporated lessons from the first house, lessons learned, and cast straps into the corners into the top course of stem wall, maintaining proper air sealing. This allowed for a clean installation of our stud walls. Both houses include a termite shield since we're located in a very heavy infestation zone. We're currently studying how this bent piece of metal affects energy loss by acting as a thermal bridge, and we log regular temperature readings at the base of each wall. Both homes utilized 2x6 construction. Our energy model determined the R value required for each wall section. At House 66, our stud cavity is filled with spray foam insulation, with 2 inches of continuous insulation run outboard of our sheathing. We included furring strips for the attachment of siding, but we realized that the number of layers to build up the wall is time-consuming. Our slightly lower R value for House 68 results in a more straightforward wall section. We utilized zip R sheathing with integral continuous insulation for our thermal break, and we did not elect to include furring. This wall section necessitated fewer steps. Zip R comes at a material cost premium, theoretically offset by a reduced cost of labor, but that savings was not realized on this Habitat for Humanity project. It did simplify installation, however. FIA certification requires use of listed products. The windows were definitely more expensive than the Zero Energy Ready home based on the performance. We have a triple glazed and gasketed vinyl window at left and a double glazed at House 68. And we learned that building to FIAS added complexity and cost to the window selection. It's hard to find a FIAS listed window locally. And designing to a high standard also requires additional forethought. We wanted to keep the face of glass in line with the drainage plane, so students built plywood box outs and paid careful attention to detail in flashing to ensure that the air sealing was uninterrupted. For House 68, we had a much more straightforward detail. There's slightly less performance built into the window, but the installation is much simpler. The most significant difference between the two houses is in the construction of the wall-to-ceiling and roof interface. Due to stringent air sealing requirements of Passive House, students framed the walls and ceiling, then sheathed and air sealed the attic floor assembly, tying into the seal at the walls for continuity, shown by the red dashed line. They then conducted a blower door test to find and eliminate leaks. Then a roof was stick framed on top of that sealed box. Again, lessons learned on the first house informed design of the second house. With a solid understanding of how to ensure a continuous air seal, students reconsidered their approach to framing. At House 68, they utilized conventional prefab truss construction with an energy heel, with the inside face of the gypboard ceiling as the plane of the air seal, again, the red dashed line. Use of conventional wall framing with prefabricated trusses provided a significant improvement to the overall schedule, and it's the typical method for drying in a house. There was one slight effect on the construction sequence. Our gypsum board subcontractor installed the ceiling, then had to take a break while the blower door test was conducted, and then was able to return to install the wallboard. This minor disruption was much less than the framing sequence of House 66. Focusing on the Fortified standard again, at House 66, the roof was added on top of a sealed box, so students tied down the roof structure with wall straps, connecting the gable end walls to sheathing of the walls below. By comparison, at House 68, the structure was tied together before the sheathing. The photo at right shows straps for Fortified applied to the framing. This allowed strapping to be completed all at once. Our process involved extensive energy modeling during design to optimize assemblies and details and to ensure that each design met its energy standard. And now we're conducting post-occupancy monitoring remotely to track actual performance. And again, to summarize our differences in assemblies, we have significantly more insulation at the passive house. Our windows and doors perform differently, which directly translates to a difference in cost. We have more air leakage at house 68, but we still exceed code by far. We wanted to see how different approaches to detailing of the air barrier at the ceiling plane of house 68 compares to house 66, especially relative to construction costs. And despite all the differences in construction, both houses had the same design HERS score predicted. Our first research question for these two iterations focuses on the cost of construction, specifically the cost of elements related to building performance. Controlling for the building systems highlighted previously and listed at right, so no interior finishes, millwork, site work. And keep in mind that these are habitat homes, utilizing volunteer labor with a few select subs, like concrete slab, gypboard, plumbing, and electrical. We found approximately a 20% delta in a construction cost. Cost us about $10,600 more to build to FIAS. And the most significant difference is at the foundation, which has a 50% delta. Now that we've established relevant construction costs, our second question focuses on operating costs. We're monitoring power consumption at the circuit level using equipment plugged into the breaker box, and we've grouped energy use into 3 categories. The first category is tied directly to the construction of the house and includes heating, cooling, ventilation, and dehumidification. We're monitoring interior temperature and humidity for both houses to ensure similar set points. The other 2 categories are highly variable because they're occupant dependent. You can see how they add up, but for the purposes of this research, we'll be tracking category 1 only. Over the last 8 months, we're monitoring energy use while still commissioning equipment for house 68. And in the process, we noticed an excessive power draw for the dehumidifier circuit. Turns out a faulty humidistat had it running continuously for the months of May and June. With that repair, our numbers have returned to a more normal spread. So how do our construction costs affect operation costs for the homeowners? A $10,600 cost premium translates to a higher mortgage for house 66, approximately $44 a month more. Thus far, our expected energy savings predicted for the FIAS project have not materialized. In fact, to date, it costs on average 8 cents per month more to operate house 66 than house 68. Granted, this cost is tied to a local power co-op. Otherwise, we might have different savings based on energy costs elsewhere in the country. But based on our preliminary findings, the Zero Energy Ready home is performing comparably to the FIAS home. We continue to monitor energy consumption and may see better results for the FIAS home in the colder winter months. We're also taking temperature readings at the base of wall in various places to understand the amount of heat lost through the foundation and floor detail, specifically understanding the impact of varying thicknesses of edge of slab insulation. And we're currently working with a number of partners across the Southeast. The knowledge we've gleaned from these iterations informs our ongoing work and helps our partners make better informed decisions about the beyond code standards they may elect to pursue. And now I'll turn it over to Mackenzie.
Thank you, Betsy. I'm going to go into a little more detail about what we mean by high performance. We'll start with perhaps this most straightforward performance metric, energy efficiency. Achieving energy efficiency is a multi-step process. As Betsy explained earlier, we model the homes during design to set performance expectations. We test the homes during construction and amend them as needed. We verify the results at the close of construction and seek applicable certifications. And finally, we continue to monitor the homes post-occupancy to ensure we're maintaining performance. Earlier, Betsy showed some graphs that compared energy use between 2 homes built to different performance standards. Here, we are comparing the actual use of house 66, the passive house, against the modeled predictions. The benefit of energy efficiency is, of course, to reduce overall energy use. But it also helps to smooth out month-to-month usage variability by reducing peaks in the hottest and coldest months of the year. You can see from this graph that our modeled energy use is a bit flatter than our actual energy use, so we've still got some work to do. As an aside, there have been multiple studies that show that energy-efficient homes have a lower mortgage default rate. We believe this is due, at least in part, to the greater predictability of energy bills. In our climate, we have pretty good shoulder seasons. However, we also have a lot of humidity, which makes the hot feel hotter and the cold feel colder. Unexpectedly high energy bills in the heights of summer and winter can lead our clients to choosing between paying their energy bills or making mortgage payments. Now back to our graphs. Category 1, which includes heating and cooling, ventilation, and dehumidification, is largely envelope driven, and you can see the actual use is relatively close to modeled use. Conversely, the actual use of Category 3, which consists of plug loads and is predominantly occupant driven, is significantly higher than projected use. There isn't much that the design of the envelope can do to affect this energy use. Put another way, if we look at the annual energy use of a typical home, as reported by Energy Star in the Berkeley lab, and break that down into our categories of energy use, an average of 42% of energy use is spent on elements that are envelope driven. But when we look at an efficient home, like House 66, the overall pie gets smaller, which is not represented here, and we are able to reduce the amount of energy use that is envelope driven. However, that means a larger portion of the pie is occupant driven. So we not only need to work on improvements to the envelope, but we also need to work with our homeowners to help them understand how to use their homes efficiently. This could be through strategies such as homeowner education courses and regular maintenance reminders. To sum up, the owner benefits not only by having a more thermally comfortable home, but also through lower and more consistent monthly bills. The lender also benefits by having a more financially stable homeowner that is better prepared to make timely monthly mortgage payments. Next, we'll dive into durability and resilience, which we think of as two separate and distinct concepts. Durability is about holding up to normal wear and tear on a building. One thing we frequently see in our service area is that homes have been modified and added onto over time to accommodate changing family need, which makes sense in our rural areas with limited housing stock. However, the connection between the original house and the additions tends to be the weak point of the home and adversely affects the home's durability. To increase durability, we're looking at alternate construction techniques such as post-frame construction, where a large roof protects a structure underneath. Conversely, resilience is the ability to mitigate and recover quickly from shocks and stresses. For us, that generally comes down to taking steps to minimize displacement. But first, we have to understand what we're trying to protect, the occupants or the asset. Sometimes these things are in conflict, so you have to assess them on a case-by-case basis. When we're talking about the protection of occupants, we're talking about sheltering in place during a storm event. In our area, that most frequently involves tornadoes. In these cases, you're detaching the shelter from the rest of the house, and in the worst cases, is the only thing left standing after a storm event. Generally, evacuation centers and community shelters can provide a safe and less costly option for shelter during a storm event. However, in this particular example, we are linking sheltering in place with aging in place. This home was designed to accommodate someone with limited mobility. The home is in a rural environment, and the combination of limited mobility and physical distance would make it difficult for the homeowner to reach a community shelter. When we looked for space to place an above-ground safe room inside the house, we looked for a small, windowless space that would not have a tendency to be filled with stuff, a tall task in a small house. So we decided that the best place to locate the safe room would be the shower. To date, it is the only roll-in safe room shower we know of. It is structurally separate from the rest of the house and sits on a dedicated foundation, but is unnoticeable once the home is complete, with the exception of the safe room door. The homeowner has hung up a small shower rod and shower curtain for everyday use. In contrast, when we're talking about protection of the asset, we look to insurance program like IBHS's Fortified Homes guidance. This program is not about sheltering in place, but instead is about minimizing damage from high winds and therefore minimizing displacement. The key word here is continuous load path. The roof is tied to the walls, and the walls are tied to the foundation, all with the goal of resisting uplift. This is accomplished through a series of Simpson connectors, which we have found do not add too much material or labor cost to the house. Special attention is also paid to the strengthening and sealing of the roof deck. When we incorporate resilience features into a home, we mitigate risk to all parties involved, and perhaps most importantly, we minimize displacement of the resident should a storm event occur. I'm not going to go as deep into aspects of health and wellness, but in some ways, it ties to the other topics we've already discussed. We usually think about the health benefits of housing as collateral effect, but we can be intentional about the positive outcomes we're creating. For example, proper air sealing and ventilation of a home, which increases energy efficiency, also helps improve air quality and eliminate dust and pests. When we think about health and wellness, we also consider a home's ability to accommodate an individual or a family's evolving needs. This is particularly important in rural areas with limited housing stock, where people are more likely to augment their current homes than purchase a new or different one because there aren't many new or different ones. Anne's home, pictured here, incorporates universal design features such as wide doors and removable base cabinets, facilitating the homeowner's changing needs. Healthier homes help reduce instances of environment-induced illness, which in turn has the potential to reduce both health insurance claims and missed work and school days due to illness. Our last performance metric today is perhaps the least tangible. It may be most easily conveyed through anecdote rather than data. With an aging housing stock, many of our rural clients are living in homes that have become largely substandard and beyond repair. Therefore, we focus on replacement housing, which we see as a third space between repair and new construction. The replacement model allows us to leverage existing infrastructure, such as the electrical meter, water meter, septic system, and driveway. Whenever possible, we keep the client in place in their existing home while the new home is built. It's also about keeping the homeowner in the same location. Many of our clients live in settlements of intergenerational kinship networks. This kinship network provides resilience to the whole family through sharing of resources such as food, transportation, childcare, and elder care. As another example, here you can see Ree sitting on the porch of her new home with her previous home in the background, and her sister lives in the house next door. Similar to the other examples we've shown, strengthening community networks provides stability for homeowners and their neighbors, and stability is key to staying on track with affording the home. To sum up, we're looking at performance in a broader context. We believe that high-performance homes are more comfortable, safer, healthier, and provide more stability, all of which translates to more economic security. Thank you, and we look forward to talking to you.
Thank you, Mackenzie, Emily, Rusty, and Betsy, and thank you to everyone who joined us today. We hope you enjoyed the presentation. We will now move into the discussant and Q&A portion of the session. As a reminder, please submit your questions via the Submit Questions Here box. Thank you. Okay, so before I begin, just a reminder that if you have any questions, please submit them in the Q&A box, and then let's begin with the questions. So first one that came through, did the neighborhood where you built homes 66 and 68 have any pushback? Did the neighborhood where you built homes 66 and 68 have any pushback about those homes not fitting in the 3 to 4 bedroom home community? I think that goes to you, Betsy, if you don't mind kicking off a response.
Sure. So thanks for the question and thanks for the opportunity to present today. For the case study houses that we presented, the surrounding neighborhood is primarily made up of 2 and 3 bedroom homes. So we received little pushback from the neighbors and the abutters. And in fact, building on these lots allowed us to maintain neighborhood density, and the neighbors were happy to have these vacant lots infilled. Additionally, these homes, construction of these homes, helped the local power co-op modify their policy regarding renewable energy, which can benefit other homeowners in the area. House 66 was the first home to install a bidirectional meter, which allows energy generated by the solar array to be fed back into the grid and runs the meter backwards. So this allows the homeowner to sell their site-generated energy back to the grid, and it reduces the cost of installing a PV system. There are no batteries.
Wow, very fascinating. Thank you. Okay, so we have the next question, which is, what is the cost of a typical energy-efficient home? Who wants to take that one? Mackenzie or Becky?
I guess I can. I'll start with an answer to that one, and it's not going to be a satisfying answer because it's going to be. It depends. There are many factors that go into the cost of a home. Who's building it, where it's built, how it's built, what are the site conditions of the home, and so we always struggle to give a kind of one round answer to that. I think what we try to do with that case study with Auburn Oak Like Habitat for Humanity is basically start with a very high performance standard. So instead of saying, okay, if we add this feature, how much cost does it add to the construction total? We started from the opposite end. So we said, all right, these are the performance metrics we're trying to meet. This is how much it costs to do it the first time. And then if we try to maintain that performance but change up the detailing, this is how much we can reduce that price. So that's kind of how we're trying to address the price, is to set a performance standard and then apply strategies that can continue to reduce the cost of those things. Another thing that we've been trying to do more and more, and I think Rusty might want to say a little bit more than me, is look at ways we can future-proof the homes. So ways that you could go ahead and put in a piece of conduit that would allow you to put in a solar array at a later date when that becomes more affordable. And that's a really small and inexpensive thing that you can do up front that prepares it for future use and accommodation of the home. And Rusty might have other examples of that.
Okay, thanks, Mackenzie. Rusty, any follow-up to that, or?
I think if you can call the one I worst for the these most and off 40s in the what we write dear struck the call to be, but all what few cuts of available and beginning about some changes years from year from deeply affordable to almost without that your world that would move to now one of the most that can.
Thank you, Rusty. I think the connection may have been slow. I couldn't tell if that was on my end or on your end, but we'll correct that. So next question, maybe for Emily, potentially. What are some of the lessons learned in your 3-county service area that can be scaled up to other geographies outside of New Bern?
I think, so what are some of the lessons learned in our 3 counties that are being scaled up? Well, in terms of the, can you guys understand me, or do I sound like a robot?
Yes, no, you sound good.
Okay, good. I mean, I think that in terms of the architecture, we take lessons from the historic houses in the region. So the houses are familiar looking to most people. They don't look as contemporary as maybe you would expect coming out of a contemporary architecture school. And a lot of that comes from the housing stock that we're surrounded by and the functionality of older homes from our region. I think that Mackenzie was beginning to speak, or in her section, she talked a little bit about the way that we recognize that our homeowners live in what we call kinship networks, or it's family pieces of property where most of the family members rely on each other to either, support childcare or get to doctor's office appointments. So I think that looking at understanding how folks, or how life and the houses that we build can support the livelihoods of our clients also. I don't know, Mackenzie, what else would you add to the scaled up lessons from Rural Studio to Front Porch Initiative?
Well, I think that kind of building on what you were saying, Emily, I think that one of the things that we have found is to make the homes where they're, kind of the most client and climate appropriate. I think we originally thought that there'd be a prototype home and you would build that prototype home. But in practice, I think what we found is if you have some prototype designs and then you have a library of building assemblies and details that you can apply to that, you can actually get a higher performing home in a greater number of areas. So for example, when you translate the home to other climate zones, you might modify the wall assemblies or the floor or the roof assemblies to work better in that climate. It's also about site and topography. And so, for example, you've built several versions of Joanne's home and used different foundation types. So then we can apply those and find something that works better to address the topography of the site, also to address how the homes are being built. We are working with some not-for-profits. They're utilizing volunteers, and then we're also working with some groups that are using a general contractor. And sometimes what's more affordable for that group might depend on who is building it. A not-for-profit might choose a material that they can get because it's donated, or something that's easier for volunteers to install, whereas a general contractor might go to something that is maybe a more costly material but saves them time on the construction schedule. So I think that kind of flexibility to adapt to different clients' site conditions and climates is key.
And I would add also, just going back to the few slides that I spoke about on Ophelia's house, that the students are the advantage of having a real client and applying, thinking about how a real person might live in a prototype and making small adjustments to the prototype is another one of our another one of our efforts to take the lessons that we've learned here and applying them to at a broader scale. So I think that what's important is that for us to always remember that people are going to live in them, and there is like an efficiency side and a wall section and a foundation, which we're all interested in, but there's also the livability aspect that we study as well here.
Sure. Thank you, Emily and Mackenzie. And to kind of go to where Mackenzie was at in terms of the next question, the 20K model excludes land and labor costs. And if these were included, how much would these homes cost in the area you currently work in? So maybe Rusty, if we have you back.
Yeah, we'll see if we work a little bit better. Sorry about that. So the question was how much the homes cost in our service area. It's very often still the sort of same sort of question. We're often of it depends. We're typically from our end, as we sort of calculate out the cost of a 2-bedroom house, we're typically in about the $45,000 to $50,000 range. Is what that home would cost in our area if it was being procured by someone else or delivered by someone else besides Rural Studio. Typically, and that's a home built to sort of base code standards. When you begin to look at quote unquote upgrading one of those homes to this sort of well beyond code performance, like including fortified gold standards that's designed to around high wind and hail durability, as well as beginning to look at that passive house energy performance standard, that can be about a $20,000 difference from one home to the other. The trick begins to look in as our team began to talk about that sort of computationally modeling the house on the front end to sort of understand how we can predict the home is going to perform, and then all the way on the back end, beginning to monitor that home to find out if it's performing, to ensure that it's performing the way it should perform on the back end. Once you begin to do those two things on the front and back end, you can begin to have a conversation about that total cost of homeownership. When you begin to see those shifts in insurance costs and energy costs, and begin to think about what else you could do with that monthly expense, where you can shift that expense of an energy payment, for instance, into an investment, into your investable asset, which is your home. What that little bit of money, monthly savings, can actually be leveraged through the power of the real power of a mortgage as a month to month, year after year, long-term investment in your home. That's ultimately the kind of the equation that we're working with, is understanding those upfront construction costs, which are where we always start when we talk about housing affordability, but really beginning to talk about what it affords, both the homeowner and the lender in this case, how it begins to shift that paradigm in really impactful ways to talk about affordability a little differently.
Okay. Thanks, Rusty. We've got about 5 minutes left in it. I wanted to definitely get to this question because I think you all would love to talk about your students. Can you tell us about your architect grads and what types of industries and companies that they go on to work for?
Well, I find I'll start, but everyone, I'm sure Rusty and everyone will add to it. First of all, Mackenzie and Betsy and I are all three graduates of the program. So some of us do things, some of us become teachers, and some of us become housing affordability research experts. It is a broad, well, architecture education is a broad way of learning anyway. It's a way of thinking and working through problems. So whereas many of my colleagues and of our past students are, directors and run and work in firms and are registered architects, I have a colleague who teaches at a high school architecture in a high school program. There are other professors as well. Some of our students leave and they never lose the bug for making things. So we have students in Birmingham, Alabama, who are fabricators of, metal fabricators who are also building the things that they designed. What are some other examples, Rusty?
They sort of do everything. We get really excited when our students go and work for architecture firms, big or small, close by, regionally, nationally, and internationally. We're fortunate that the program has an international reputation, and our students are able to go, kind of anywhere that they want to work. So I think the question becomes about what are some of the places, the kinds of places that they want to work is interesting, and how our students are beginning to shift the attitudes and the places that they work are really important. A long time ago, a guy named architect named Friedrich Kiesler, back in the 60s, he sort of made a list of things, important things that you needed to be or accomplish to be an architect. And the very first thing he said, you need to be 50 years old, which historically is sort of true. To be an architect is an old person's profession. And so if you think about our oldest graduates, they are just now getting somewhere close to 50 years old. And so it used to be harder to answer that question, but now they are kind of in leadership positions, and how they're changing, wanting to have a value-driven work in a value-driven place becomes really, really important. I think the other thing to think about too is it's honestly not just where our students go, how they leave us, but this is really, really important for the audience to hear, I think, is actually how young people come to us today. There's a lot of challenges in the world that we face. and the future sometimes around a lot of the topics that we're talking about around environmental stewardship and equity and those sorts of things that we're really anxious about at the moment are real challenges. But what I can tell you, the way our students come to us today, they're absolutely remarkable. The work is their work, both the design and construction. What they can accomplish, what they want to accomplish, how they want to change the world is stunning. And our sense is that once we kind of get out of the way a little bit, which I think is a lot about what we do at Rural Studios, we provide an opportunity for young people to do the things that they want to do and make the world the way they want it to be. When we get out of the way a little bit, the future is bright, and it's going to be a-okay. I think that's our graduates come to us with those sorts of ideas, and we hopefully sort of give them the tools to execute those desires for their future and the future of the world that they come to us ready to live in.
Thank you, Rusty, for that sort of passionate answer. So we're up. We're basically out of time, unfortunately. Please join me in thanking Betsy, Emily, Rusty, and Mackenzie for joining us today and showcasing their terrific efforts to increase the supply of affordable housing in rural America. As a reminder, the session recordings will be made available at the end of this conference. The deck for this session will be posted at the Resource Center. And please visit the Rural Studio website and Twitter accounts. We value your opinion. Please take a moment to complete the survey for this session. Thank you for joining and have a great day. Bye, everyone.